Welcome everybody. Thank you very much for coming to the first online DevOps Belfast. Thank you very much to Paul Stack from Pulumi for coming along and speaking tonight. He's going to talk to us about infrastructure as code and what happens after Terraform. Is that fair to say, Paul?
Yeah, it's exactly it when you mature.
Just to sort of give you how we're going to run tonight, Paul's going to do his talk and demonstrations here. I'll be collating questions through chat and we'll interrupt Paul with those as we go along, and then we'll open up the floor at the end just for discussion and any other questions. So thank you very much, everybody. I'm going to hand over to Paul now.
Nice to speak at a local meetup. So I'm from Derry, just not that far away. I don't know where everyone's from. My beer tonight is actually sponsored by Pulumi, which is great. Sorry that I can't send you all a beer, but I'm sure you'll all cope. So tonight is a talk software. I'm not going to call out if anybody actually knows Pulumi or not, because it's kind of pointless in the system. But Pulumi is like a new kid on the block in terms of infrastructure management, and it's very much around actual software because it uses real languages rather than actually using DSLs. So it's got a different mental model to like tools like Terraform and CloudFormation and Azure RM, but it works in a similar manner. So like we have a number of people at different levels in the cloud transition ecosystem. So we have like level 1 where you've just picked up your physical data center and you've just moved to the cloud. Everything is extremely like end-tier based. So you have application web servers, you have database servers, and you have a cluster of them, and you largely like use like configuration management style solutions in order to manage those pets of your web servers in the cloud. Then you have people who have moved to a different level of management, and they've realized that you don't have to manage your own database servers, for example, and you can take advantage of managed services like Aurora or MS SQL or all these different things, and then you can start to integrate like agents like Datadog or Honeycomb or all these different things, and you can probably start to take advantage and experiment with containers and stuff like this. And then you've got like people who are at like V3 of the cloud infrastructure movement, and like we're in very much an interconnected microservice based architecture that probably uses something like a container orchestrator and like is passing data, maybe even multi-cloud and serverless as part of it. And there are tools to manage all three of these parts of the ecosystem. Okay, so like V1, you can very much have, all tools can do it: CloudFormation, ARM, Terraform, Pulumi, and then you even can have like configuration management tools that will actually interact with it. V2, you start to have to be a little more specialized in your tooling. Maybe you can still get away with your configuration management tools, but you're still in a situation where you would need to take advantage of Terraform or Pulumi or CloudFormation and stuff like that. And then you have V3. So V3 is very much where Pulumi's sweet spot is. So Pulumi is designed in a way that it has lots of syntactical sugar to allow you to make life a little easier in the cloud rather than actually just having to define raw resources, because it uses real languages. It uses real the language ecosystem, which means you can start to take advantage of packaging and start to take an example of layers, take advantage of layers of abstraction and all these different things. I can show you some of these examples as we go through, of course. Now, for us, we actually believe that we're modern infrastructure as code because, let's be totally honest, people have been calling it infrastructure as code now for years, and people haven't really written any code. It's usually JSON or YAML or DSLs, or you've even had a generator that actually generates these for you. So like template engines and so on and so forth. We can, because we're languages, we allow you to like integrate your reviewing, your testing, your versioning up front as part of like real software. We have continuous integration workflows, and we have like strategies around policy management and stuff like that. So for those who are HashiCorp users, we have an equivalent of HashiCorp Sentinel, and you can actually introduce that into your workflow. Everything I'm going to show you here today is open source, so you do not have to pay for it. It's not like I'm trying to sell you on Pulumi. I'm trying to sell you on the fact that we are at an evolution of infrastructure as code, rather than sticking with the traditional what everyone knows and what everyone has been doing. So you create it using your language, you use your IDEs, your testing, all your different tools, your developer workflow. You deploy it. So it is a CLI, allows you to preview the changes, integrates into CI/CD, and then you manage it. So you get all of the interactions and your audits and everything that goes with it. So the way Pulumi is made up is that we have a basis of providers. So we have AWS, Azure, Google Cloud, Kubernetes, New Relic, Datadog, Cloudflare, VMware, OpenStack, DigitalOcean, and like 30 others, okay? Any provider that is currently a Terraform provider can actually be made to a Pulumi provider in a number of easy steps. I will actually be recording some videos on that later in the week. And I think I've got it down to 4 easy commands in Bash, which will actually allow you to do it and scaffold the provider. On top of that, we have a number of like libraries and which are like common patterns and practices around it. So this is taking advantage of inside Pulumi, what's called the component resource, which I will demonstrate to you a bit later, which allows you to create these reusable, more flexible APIs that a lot of developers have been using today. And then on top of that, we actually have created this idea of Pulumi Crosswalk. So Pulumi Crosswalk is like best practices around deploying and managing your infrastructure in the most simplistic way possible. So again, we're going to have a look at how Crosswalk works in the demo, because you have to see it to believe that it's actually there, because it is literally one line of code which will deploy a VPC with subnets, with internet gateways, with NAT gateways, with route tables, route table associations, and all these different things in AWS. We also have this same ability in Kubernetes, because Kubernetes is a huge ecosystem for us. And the difference that between us and other tools out there is that you don't actually need to know all of the provider-based implementations up front. We do not generate a full DAG in advance. We actually will lazy load the DAG until we need it, because we're an imperative program. And at that point, you can actually have the outputs of your cloud feeding into the inputs of a Kubernetes provider or a Docker provider or whatever provider, all in the same workflow. And at that point, you can actually then manage the Kubernetes stuff. So in terms of that, it actually allows you to do different pieces in a much more flexible way than needing to know everything up front. There are 4 main use cases. So we're going to start at the top right. I don't understand why I've created the slides to the top right. So you have traditional infrastructure, where you actually define your infrastructure resources. So your security groups and your instances. And notice we can actually take advantage of constants, and we can actually specify, still actually be able to specify relationships between the resources. Then we have containers. So you can create a layer of abstraction called, like in this case, it's actually, there is one that exists called Pulumi Cloud, and you can say a cloud service, and the cloud service will effectively be a wrapper across the top of Docker, which will actually build and deploy a Docker container. So in this case, it would point to a local file on this called app. It would build it, and it would actually push that up into your system. Then we have Kubernetes. You can see that we've actually abstracted a function from Kubernetes, where we can reuse and recreate small pieces of code in order to actually just pass in like specific variables. And then lastly, we have serverless, where we've actually made it extremely simple to be able to create the glue between serverless applications and the infrastructure to deploy them. So here we're creating like an API gateway endpoint, and then inside the API gateway endpoint, we're associating a route, which will be just a catch-all route. And then we have an async func, which actually gets packaged up and deployed as a specific Lambda and associated back to the API gateway. So there's a lot of syntactical sugar that actually makes life a little easier for developers here. Even though we are real languages, we are declarative. What you specify is what we will achieve, but how we get there is slightly different to other tools. So we will work our way from, it's a typical application, and because it's a typical application, it will actually be able to work its way down the page. And if you have to specify, you have to actually specify relationships between the resources in order to actually make those happen in a specific order. Otherwise, Pulumi will try and do everything that it can in parallel. So you can see here in the second example in the instance, we're actually referencing the group.id. So we're actually specifying to Pulumi that a group has to happen before an instance. Now, that's a conscious choice because you don't have to build this huge DAG up front, as I said. So DAG being directed acyclic graph. So understanding how everything walks the tree, Pulumi will just try and deploy it and manage it for you. We're real languages, so we can easily take advantage of conditional logic and loops. Like these are basic programming primitives that we shouldn't have to shoehorn into systems. I know like Azure are starting to add some new stuff into Resource Manager, and it's making the syntax look, I'm going to say interesting. I'm not going to slag off any tools today. It's much more around the case of we can take advantage of the language ecosystem just to like have our full programming constructs and models. We have multi-provider workflows. So like I told you, it's a case of you don't need to know all the different pieces up front. You can actually feed information from one resource into the other and even into specific providers. We have reusability. So you get advantage of the full packaging ecosystem of the language that you're using. So you can have PyPy, you can have NPM, you can have NuGet, and then you can just use like Go modules. And then the more interesting thing for us is that we can actually have advanced orchestration. So what we're doing here is we're deploying 3 replicas of an application to Kubernetes. We're then calling some code inside the checked app metrics function, which actually calls in the Prometheus API. We're making sure that the Prometheus API returns like after a certain period of time that everything is consistent and that no metrics are going crazy. And then we continue with the next 10 replicas of the deployment. So you can really start to take advantage of pre-existing code and pre-existing APIs that have been created in the ecosystem already, just by the fact that we are a language and you can just NPM install or you can PyPy install all these different things. And then lastly, Pulumi 2.0 has introduced this idea called superpowers. And one of the superpowers we have is test-driven infrastructure. And when I mean test-driven infrastructure, I really do mean test-driven infrastructure. You do not need to have cloud credentials on your local machine when developing cloud resources. We actually, Pulumi can mock the responses from each of the clouds. And because we can mock the responses from the clouds, which are well-formed, well-known responses, we can actually test the logic that we're using in order to create the cloud resource. If anybody's interested in that, I can show you some code in that a little later, because I gave a demo and like a meetup talk on that this morning. And it's extremely powerful what you can do with it. So let's go and write some demos. Any questions so far?
Paul, just one. This is all still desired state modeling, so you still have the ability to track drift and correct drift. This is not just a wrapper around calling cloud APIs.
Correct. It manages state, and because it manages state, you can actually understand if someone has changed anything at any point just by running a simple preview or a simple refresh, and it will actually tell you what to do. So Pulumi is a CLI. If we just run the command Pulumi, it's actually quite an instructive CLI. It tells you what the most common things are. But the more important thing is you see at the top, it says to begin working with Pulumi, use Pulumi new. Okay, so I'm just going to make a directory, demo 1, because I have quite a few demos here. And I'm going to Pulumi new, and it's an interactive CLI by default, but of course you can turn that off. And it asks you what type of application that you actually want to scaffold. Today, I'm going to choose AWS TypeScript, just because the TypeScript ecosystem is extremely rich in Pulumi, because one of the creators of TypeScript is our CTO. All languages are created equally, but the ability to create, the ability to take advantage of some functions in TypeScript allows us to have a little more syntactic sugar as of today, so as in mid-May. It will ask us a project name. So let's say DevOps Belfast Demo 1, description, and a stack name. So stacks in Pulumi are the ability to run the same code resources multiple times segmented from each other. So if you think of stacks being environments, so you can have a dev, a test, a staging, a prod, whatever environment names you use, but also individual developers. can have their own stack. So developer one can like be testing their own individual code and their own individual commits, and it can be completely independent from the other developers in the team. Today, we're just going to say stack name. And lastly, because it's AWS, it'll say, where do you want to deploy this? I am not going to use ES. No, I broke EU West 1 last night because I removed an internet gateway in the demo. So it's JavaScript, so it's just going to install the entire internet, which will take 2.5 hours, 3 hours, something like that. And we actually now have a scaffolded application. So let's have a look at what it's doing in the application. So the application by default has just 2 things in it, okay? 3 things. Firstly, it has all of the imports. So here are all the packages, the Pulumi packages that you can take advantage of. So Pulumi is for the helpers, AWS is actually for the provider, and AWS X, which is like a layer of abstraction across the top, which I'll show you in a second. Then we create a resource, and Pulumi can actually deal with exports. In this case, we're actually exporting directly how the language ecosystem, because it's TypeScript, we can see that it's an export of constant. Now, everything in Pulumi is actually packaged in a similar way to how AWS is. So if I say const x equals new AWS dot, you get all of the packages. So EKS, EC2, ACM, ALBs, application load, but it's a different one, backup, CFG, CloudFormation, all these different things. But today we're just going to take advantage of an S3 bucket. So I'm going to say demo 1 again. I've been caught giving away my credentials a few times, and on recorded calls. So I use a tool called envchain, but this is actually reading my environment variables. There are no AWS environment variables on my machine. And if I envchain Pulumi AWS CI, Pulumi up, the first thing it's going to do is it's actually going to check the desired state. It's basically going to say, does anything exist right now? If it doesn't exist, or if it does exist or doesn't exist, tell me what it's going to do. So the first thing it has to do is create a stack, because this is how it relates back in the console. And then it says it's going to create a bucket. We can say yes, it's going to deploy that bucket. And we can see the ID of the bucket, which will be the name coming out the back of it. Now notice one thing when we do this, and this is where Pulumi differs highly from all of the other tools available. I'm tethering on a 4G connection, by the way, so it'll be a little slow, I apologize. Now you see that even though I specified the name as my bucket, Pulumi applies auto naming by default. The reason it applies auto naming by default is that there are a lot of operations in the cloud, and there are a lot of operations that must have replacements before you must do creations before deletions, or you can. Another way to say it, you can't reuse the same name twice. So we try and do it in a HA way where we create it before we actually delete it. Bucket is an example of this, but we can override that at any point, because a Pulumi resource has 3 items in its constructor. It has a name, which is used in the auto naming, so that's part of the state. It has some arguments, and then it has Pulumi custom resource options. I'll come back to the resource options a little later because they're a little more interesting and a little more in depth. But here I can actually specify the name is demo 1. I'm really hoping nobody has snagged that specific name. And if we Pulumi up, it'll actually tell me that it has to create a replacement, because you can't change the name of a bucket. A bucket actually, you can't even do that in AWS CLI. It actually will create a new one in its place, I believe. But you'll see that it's got 1 to replace. The details it will tell you, it's going to create a replacement, and the replacement will go from my bucket name that to a specified hard-coded bucket name, because we have specified that that's the case, and we can say yes. Now, Simon, you asked the question about tracking drift and tracking state. There are a number of things that happen in the background when you create a bucket around acceleration status, and around all these different things that are not available when you actually first create it. That happens sometimes in the background, and I'll explain why we don't get them in a second. But if I Pulumi refresh now, it will tell me what it actually has to refresh. And this is going to uncover a bug in a second, but that's okay because there is an open issue to fix it. And it will tell you all the different pieces that it actually has to refresh. And it will refresh that state. Give it a second. So while that's happening, there's a question from John McCabe. How do you keep up with provider API changes? And our providers auto-generated or manual? So, okay, so it's no secret. Terraform builds its providers on top of Pulumi. So we are at the mercy of.
I think you mean the other way around, Paul.
We build our providers on top of Pulumi. What were we going to say, Simon? Sorry.
You said Terraform builds their drivers on top of Pulumi.
Oh, sorry. Pulumi builds their providers on top of Terraform. So we are at the mercy of the Terraform providers. As of May 2020, that is the case. That will not always be the case, but we will always coexist in the Terraform ecosystem because people have already created a large amount of infrastructure in the Terraform ecosystem. So there will always be a way that you can actually generate providers based on Terraform. So we have a rule where we have a number of, like, we're going to call them first-class providers. So Pulumi, AWS, and GCP are certainly members of that. And we aim to have those updated based on Terraform within 24 hours of the upstream Terraform changes. And, you know, they're pretty fast at getting new releases of Terraform out for new features. So we are a little bit behind upstream changes, but not too much. It's important to say, though, that the Kubernetes provider is actually only 15 minutes behind the Kubernetes API because we generate it from an open API spec. And the only reason it takes 15 minutes is because it takes us 15 minutes to spin up an EKS cluster. We don't keep them warm because it's like a pointless cost. And it's a really simple way of being able to like generate our EKS structure. So I hope that answers your question, John. I'll come back to the mocks and part of your question a little later. So we're going to say no to this refresh change. And then lastly, I can destroy it. Actually, firstly, let's Pulumi stack export, because at any point you can get a checkpoint of the state file, and it has all of the different pieces of information in the outputs. So it has the ACL, it has the ARN, the bucket, bucket domain name, all these different pieces. And that is a checkpoint of your provider at a point in time. The URN for our structure is slightly different here because we try to take an approach that allows you to refactor it easily. I know that some people have complained about modules in other tools and about how when you create a module, if you need to move things around, you basically have to state remove and state add and so on. Our structure is really simple. First thing is we have dev, so that's the stack. Then we have DevOps Belfast Demo 1, which is the project name. Then we have the resource type. And lastly, we have the unique identifier, so the my bucket. And then I can actually destroy, and we can, it'll tell us like everything that it requires in order to destroy. Now, it's important to say it's a great question. It's just coming, is it possible to run self-hosted, both for personal use and for enterprise use? Yes. By default, Pulumi, who am I, will show us that I'm using the backend URL of app.pulumi.com. So if I Pulumi login, cloud URL, I can give it an S3 bucket. I can give it a GCP bucket. I can give it an AZ blob. I can give it all these different pieces of information. And if you have a look in Pulumi login help, it will actually tell you how that you can store your state in local places. In fact, you can Pulumi login, file, and if you really want to, you can store it to your local machine. Yes, we support self-hosted enterprise editions as part of our SaaS. And just to show you what the SaaS would show us, app.pulumi. I have a feeling this will make me log in. I very rarely log into the console. No, it's there. And if I DevOps Belfast, Devo 1, you can see the project, you can see the stacks inside it, and you can see any outputs that are configured, any tags that are configured as part of the application, the full audit trail of everything that's happened, even if they haven't proceeded. So if they were like previews or refreshes that were never actually completed, we can see everything there, and we can see the resources that are there as part of it. And you can, even if you really want to, turn on a graph of seeing how the resources map. Everything is actually inside it, and of course that's the paid for feature. So let's close that because that's not why we're here. So let's actually deploy it or destroy it, and we'll say Pulumi destroy yes. Let's go and create something more interesting. Now, secret management is huge in Pulumi. Secret management is one of the things that we believe makes us different from everyone else, because it's a first-class solution rather than needing external tools as part of what's going on. So I am just going to npm install at Pulumi/random, which is just a random, it's just a package that allows me to create random strings and random passwords and stuff just for the purposes of a demo. And we can actually import star as random from at Pulumi random. So let's say that we have a secret or a username and password that we actually want to encrypt and do something with. So I'm going to say const my password equals new random password. I'm going to say, and in terms of trying to be good, let's give it a password strength of, or length of 30, and let's add special characters to it just so that we can actually see what's actually in here. If I export that constant value equals my password, I know that the result of that is actually stored in result. And if I go and Pulumi up, let's just say yes and skip the preview, because we're going to like pretend that we understand that that actually happens, and we know that that's something we don't care about. Unfortunately, like other tools, it will just paste the result in the state. Like it's in there. There's nothing really we can do about it at this point. But I can copy this block, and I can say my password 2, and I can take advantage of the Pulumi custom resource options here. Pulumi has a secret engine built in by default, and to access the secret engine, you out of the box it uses the Pulumi KMS because I'm using the Pulumi SaaS. But if I Pulumi stack init help, you will see that it supports AWS KMS, Azure Key Vault, GCP KMS, and HashiCorp Vault. Okay, but right now we're just taking care of the default secrets manager, and we can say we want to pipe the result of secret out of that. It's important to note that even though we saw it before on the terminal on the output, we actually also store the secret in state until we actually take advantage of the secret engine. So let's say my password value 2, which calls my password.result. And if I Pulumi up, then we'll actually see that the secret, the second secret that comes back as a real secret value right here. And because it's a secret value, we can see even in the state file, we can see it has actually been encrypted. So that state file, even if the state file is leaked, it's no problem, because unless they have access to the Pulumi stack and the Pulumi project, the KMS key won't be available for them. If there's a leakage in AWS around KMS keys, we've probably got a bigger issue than just this specific secret. So anything can be passed through this additional secret options, any of the outputs that come through it. So like you can actually like say override special as part of it, and any amount of outputs. So if you think of like initial passwords for AWS RDS or so on and so forth, we would suggest that they get pushed through the secret values. So there is a question in here about what's the multi-user experience around shared state. By default with Pulumi, the Pulumi SaaS, there are locking mechanisms that stops multiple people hitting the state at the same time. If people do that, they'll get a 409, which it basically says an update is currently in progress. If you're using the open source backends, S3, GCP, so on and so forth, as of mid-May 2020, that is not the case. It is not, there are no locking, so you could override each other. In order to do it, you would actually need to implement your own locking functionality. There is an issue open, which will allow us to address that. We just haven't got to that yet. So let's talk about AWS X. So firstly, let me create a new stack. Let's create a new stack in here because I've just deleted my old stack, and we can Pulumi config set AWS region US West 2 because I want to deploy my applications into US West 2. So import star as AWS X from @Pulumi/AWS X. Now what AWS X allows us to do is wrap up a lot of different functionality. Okay, so if I say const x equals new AWS X .ec2.vpc, and I'm going to say my VPC. My VPC. And because we're taking advantage of TypeScript, we can actually see what it says. It says expected that there was no arguments supplied. So let's supply the arguments that are required. Just empty arguments, in fact, we can do by default, and we can specify it. Now, we would expect this just to be a VPC, but this is not just a VPC. If I Pulumi up here, what this does is this wraps a number of resources behind what's called a component resource. Component resource is like a module in Terraform. It allows you to wrap a number of different pieces together to create an API across the top that your developers or your operators can actually see. But we can see by default, it creates an internet gateway. It creates a route table and routes and a private subnet, the route table association, and the route that goes with that. Another private subnet, and then two public subnets. It creates an elastic IP or two elastic IPs, two NAT gateways, and it does everything around the actual VPC itself. So it allows us to create very simple APIs around the back of the different pieces of information. But one thing that is important to show you is we can actually do this in a slightly different way. So let's pretend that you're a Kubernetes shop and you have a Kubernetes infrastructure team, which there are Kubernetes infrastructure teams out there today. The deployment of a Kubernetes cluster is actually got a lot of moving pieces to it. So sometimes asking developers to know all of the different individual pieces around that is actually extremely difficult. So let's say, firstly, let's create a project name. We can actually say const AKS cluster equals new AKS dot cluster dot AKS. Come on. If I can actually spell it right. And we can pass in project name. Actually, let's pass it in as the promise rather than the raw variable. And so it's actually going to pass it in as a string. What I'm doing here is I'm building an API from a user-facing standpoint so that I can build a nice, simplistic API for a developer to actually take advantage of. So we'll create AKS.ts. We'll import star as AKS from AKS. And then we can actually start to take advantage of what an AKS cluster in here will look like. So we can do a number of things. Firstly, we need to import star as I don't have the package installed. Let's actually go do that. We say no, npm install package Azure, from at Pulumi/Azure. We can say export class AKS cluster extends. This is why TypeScript is extremely good, because TypeScript gives us inheritance. So we can extend Pulumi.component resource, which allows us to wrap and export this as a user-facing API. Let's say import star as Pulumi from at Pulumi. And we can really take advantage of a number of different pieces in here. First thing we need is a constructor. We're just going to copy and paste this code because I don't want you to have to watch me write all these different pieces. But effectively, we've written a constructor which allows us to wrap a number of pieces of functionality away from the user. And now we can create all our resources in here. And as far as a user is concerned, all they need is the package of AKS, and they can, you within your organization can write your own APIs across the top of the cloud, which allows you to hide away a lot of the complexity that each of the developers can actually do. Let's change tactic a little bit. IAM policies. IAM is one of the things that we all use if we are in the AWS world that we very rarely remember the syntax of using. So for example, assume role policies, or the different JSON document formats that you actually need. So Pulumi has created a number of helpers here. So let's AWS import star as AWS from at Pulumi AWS. So usually if it's a local meetup, like a physical meetup, I would give a prize for anyone who can tell me the JSON structure of an assume role policy in AWS. But of course we can't do that today. So I say const role equals new aws.iam.role. And we're just going to call it my role. And then we have assume role policy. Now here is actually where you would have to do like, if we didn't have the helpers, we could do pulumi.interpolate, and we could take advantage of all the different pieces of it. But we don't need to do that. We have created helpers which allow you to say aws.iam.assume role policy for a principal, and we need to say a service, and we say ec2.amazon.aws.com, and that will print out the required JSON under the hood in order to do it. But you can see it's strongly typed here, which means it's much simpler to actually see how it's running. Then we usually have like policy strings that have been created in advance. So we have these policy ARNs, and those are difficult to understand as well. So we can say aws.iam.managed policies and you get autocomplete for all of the managed policies. So for example, container registry full access, and it is actually a string under the hood inside the package, so that you don't actually have to know what it's doing. We can take advantage of conditionals and loops. So let's say let counter equals 0. And I can say for const policy of managed policy ARNs. Const RPA equals new aws.iam. I'm missing a brace, I apologize. Dot role policy attachment. We can take just everything has to have like its own custom name because of the Pulumi state. So we can say my RPA dash $x plus plus. Oh, excuse me, count plus plus. And this is again where we're a little different from other tools because we're strongly typed. So the policy ARN can be policy, but usually you would need to pass like a role ARN or a role ID, and sometimes you don't know what it is. So in Pulumi, you can just pass the entire role that was created above. We don't care. Pulumi will understand under the hood if it needs to be the ARN, the ID, or the actual name of the role itself, and that will actually allow us to loop over and create all of the individual pieces. And then lastly, we have policy documents. So if I say const my policy equals, excuse me, which is an AWS IAM.policy document. The policy document is an actual struct. So we have a version, and you can see you have autocomplete. So let's say 2012. We have statement, which is an array of objects. We know, look, it's telling us what we're missing, because actually statement actually needs some things, and it's telling us exactly what it's doing. So it's missing the following property documents. It's strange that I don't get the full output here. So the first thing we need to do is, like I used, like you can give it a SID, you can give it an effect. The allow would be the effect, and we can see that we've actually got a real policy document. We adhere to something now. We can say principal is star. We can say our action is, let's say, S3 star. I know we would never do this in production. And we can say resource will be like star, okay? Now, because it's a typed document, if I say disallow, it's going to basically say, hey, there's no such thing as disallow. It's either allow or deny. And if I say my principal, if I spell something wrong, it will also come back and say that doesn't exist. You know, it doesn't exist in the properties. Look in the documentation in order to see it. So you're getting strong typing in order to understand that. And we can attach that to a bucket. I can say const my bucket equals new aws.s3 bucket. I can give it a policy, and the policy will be my policy, which will be a policy document. So policy we can see as a string because of the typing, or a policy document. A policy document is a real hard-coded system that actually allows us to be auto-generated and passed around. I have one more example that may be of interest, may not be of interest, but we're going to try it anyway. Okay, so Pulumi has a tool that allows us to coexist with Terraform called TF2Pulumi. And TF2Pulumi effectively allows you to scaffold changes, scaffold an existing Terraform application as a Pulumi application. So sometimes it's useful to show people that it exists. And I actually do know that people are using this today. So I think I had some work in here. So we have a number of examples. Tests, Terraform, AWS. And in here, we have a number of pieces. If I go and have a look at EIP, for example, yeah, there we go. So we have an existing application. The application is a Pulumi application, or a Terraform application, which like creates an instance, it creates a security group rule, it creates the provider and the Elastic IP, and we can actually just do something like Pulumi new AWS TypeScript, and we can pass a directory. Actually, I need to make it first. Pulumi new AWS TypeScript. The dir will be sample conversion. That is fine. USE1 is fine because I'm not actually going to deploy this. And if I cat sample conversion index.ts, you'll see that it's just the basic sample of everything else. Oh, I don't have the binary. Amazing. tar. There we go. And Apple might ask me to verify its identity because we don't currently sign it. That's fine right now. This is going to be going to Homebrew Tap very shortly. And open, just to verify. Okay, excellent. So what I can do is I can say TF to Pulumi, and I can say into sample. TF to Pulumi. Why are you not working? Into sample conversion slash index.ts. Oh, wrong folder. That's why. I apologize. TF to Pulumi. I got super confused there. Into sample conversion index.ts. And now if I cat sample conversion index.ts, you will actually see that it has scaffolded all of the different pieces required. So here's our Elastic IP, here's our instance, here's our security group. And notice it has ordered them in the correct way in order to actually build and scaffold the entire application. Okay, so that's 50 minutes of demos taken care of. If anybody has any questions about the demos, please go for it.
I'm going to unmute you all now. So I think, John, you've one unanswered question about policies that maybe get us going.
Yeah, so kind of policies increasingly becoming like a critical part of getting any new infrastructure deployed. Like we're, for example, using OPA as like sort of the common policy enforcement tool. So we're able to kind of integrate directly with Kubernetes, and we're also able to work directly on sort of Terraform plans. Do you have a way of integrating with the likes of, OPA or Sentinel or other policy agents?
So Pulumi actually has its own policies, and takes advantage of, firstly, we have Pulumi policy OPA, which allows you to run OPA rules built in. But I'm just going to quickly show you part of the demo I gave this morning. So if I DevOps Gothenburg and I open my browser, so effectively, if it ever opens, I apologize. This is the mock-in stuff, so we don't care about that. So we can take advantage of Pulumi policy, which allows us to test individual components. So this is where you would enforce, here is just validation, of course, but this is only because I adapted it for a demo. But for GDPR, for example, you can enforce that infrastructure is created in the specific location. It is tagged. It doesn't have leaking security groups, everyone can access them. And as part of your Pulumi up, you would say policy pack, and you would just point to the entire repository, and it will actually run across all of the policies as part of your policy pack.
Is it
part of your
possible?
Infrastructure.
Is it possible?
Sorry,
is it possible to decouple that from the main repository? Because I know we try to be adversarial in terms of enforcement. The risk is that if it's all in the same repository, you don't have an easy way of limiting sort of developers changing things.
Oh, yeah, absolutely. I apologize. So this was a demo purely for the sake of experience, that it just point into a folder on my local machine. This can point to anywhere. This can point to any location, any folder on disk, anything like that. But this is because I'm not taking advantage of the Pulumi SaaS. If you take advantage of the SaaS or the enterprise version, then by default, the policies will run against your code without the developers even know that the policies exist.
Sounds cool. Thank you.
Who's next? No one? Quiet bunch.
And I think Simon kind of made the point earlier about under the hood, it resolves to a DAG. Have you seen anybody wanting to take a more dynamic approach? Like, can you use it for a more dynamic approach? Like, you know, the Tosca standards where like you can actually model life cycle type things rather than just a single desired state?
Wonderful question. Okay, it's probably best to show you an example of this. Yeah, let's show you a specific example. So with Pulumi, it's like out of the box, it has like resources, and everything resolves to individual resources or APIs like component resources. But Pulumi also has this idea that we have what's called the dynamic provider, where you can manage your own CRUD API access. So you can define your own create, read, update, and delete functionality. So if I show you what I mean here, code, cd go, source, GitHub, Pulumi, examples. And the examples repository on GitHub shows you like a ton of information across a ton of different clouds in a ton of different languages. But we have a specific example that we see that, where are you? Yeah, so in Azure, there's a lot of functionality around CDNs that are actually not available as part of ARM, and you have to shell out to CLIs and all these different things. So what we've done is we've specified a Pulumi application where we've created the resource group, we've created the storage account, we've created the container and the CDN profile, and then the endpoint. And then now we've created a new domain resource, which we just call a new domain resource and pass in parameters into it. And then Pulumi understands that if it's part of a read operation, it will run the read operation functionality inside, or if it's update or delete or so on and so forth. And we can see in here, you can write your own functionality. So there's your functionality for check, there's your functionality for diff, there's your functionality for create, read, delete. You can actually have full control of exactly what it needs to do here. So this allows you to shell out into APIs. This allows you to talk to different HTTP endpoints or anything that you actually needed to do. I know of a bank in South Africa that are actually using this in order to provision, as part of a Pulumi up, it's actually calling a script on a central machine that's actually provisioning a vSphere cluster as part of what's happening, because they actually want to audit when, who created what and all the different pieces, and have full access of who's doing it. So you can have full like control over exactly what you want in the life cycle, and you can skip individual pieces of the life cycle just by creating your own dynamic resource across the top of it. Does that answer your question?
I think it was slightly different. I'm talking about kind of like the case where you would be kind of effectively running it in like a form of reconciliation loop, and you could change your configuration based on some external sort of endpoint, you know, while you're running, you know, so like, you know, rather than just being like, I have a single desired state, I have a single desired state that may change over time based on some external, you know, are you seeing people using it for that?
Yes, I see what you mean. So right now it's CLI driven only, but there is an issue open in Pulumi, and I believe it's actually one of our most actively like changing features. But there is this idea that's called a runtime API.
How different is that from the Prometheus example you gave earlier on, where you go halfway through building something and then you call an external API to decide what to do next, or to decide
that's effectively what a dynamic resource is right now.
Yeah,
like that's you're putting the logic in the dynamic resource, which says call in this API, call in this package. If you have meet all the success criteria, then return. Otherwise, error out, and at that point, the Pulumi application will stop. But I think what John might be alluding to here is the fact being able to control the loop based on, you know, being able to push external configuration in or control the configuration. But that's currently not possible without this runtime API, which will allow us to set this configuration dynamically based on what's happening. So, you know, if there's an external factor that something actually needs to change, you can get the external factor to push in a new configuration value, and then the loop, the Pulumi loop, will actually run in a different manner the next time.
Cool, thanks, Paul.
So there was Christy said, maybe John thinks it's something related to what Kubernetes is doing to constantly monitor the state of the resource and get the state. Is that right, John? Is that maybe what you're doing?
No, it's more like there's like the Tosca standards about application lifecycle modeling. Like Kubernetes is kind of just desired state as well.
Yeah.
This is kind of about modeling the case where, yes, you can have desired state, but in transitioning from one desired state to another, there can be certain, there are things you need to do that are different to the initial provisioning.
Got it. You know what? Ping me, stack72@pulumi.com, and I'm positive I will be able to point you in the right direction specifically. Around that, I just need to talk to like 1 or 2 different people in the team in order to do it. With regards to what Christy said, pulumi.com/blog. So we actually created a query library where, really? Let me find where Kubernetes is. So we created a query library that you can actually understand what is going on inside, like, for example, your Kubernetes cluster. And you can ask it a number of questions, like give me all the lists of a specific piece of software that is currently running inside my pod. And then, so you can ask it questions, but you can also stream queries. So you can start to see what is actually going on in a specific cluster. And then, of course, because you're actually running the code, like if it's a specific thing, here we're just actually console logging. But of course, you could actually instruct Pulumi to create your own custom code. Like, if something happens that you shouldn't, you would like alert, or you would stop something from happening. You can write your own custom logic in here in order to stop something from going on if it's adverse to what you want. Any others?
I think you've stunned them into silence, Paul.
Or people just don't understand why I'm here.
It's the accent. They couldn't get a hold of the accent, even though it's only 70 miles away.
So Pulumi 2 is out. Pulumi 2 gives us a lot more pieces of control than we ever used to have before. I talked to you earlier about the testing, and what we can actually do in the testing is you can actually start to write specs. So you can describe your individual infrastructure. You can actually run tests across your individual infrastructure. And I said that you don't need credentials on your machine in order to do this. So we can actually mock any calls to create a new resource. And if it's an AWS VPC, then if we need something specific around the VPC, we can return specific information that we can understand, like custom logic that we have written in order to deploy our VPC. Otherwise, we can just return defaults. If we make a call, which is the same as like a data source. So this is where we would make a call to, like, let's say, get the availability zones inside a region. We can mock that resource as well. And because we're doing that, like, things actually run a lot faster than we can see. And if I show you, so if I mock like my infrastructure tests, it's going to give me like 4 results back from my infrastructure tests. And we can see that it's actually like running everything. Again, just to show you, I have, this will be embarrassing, so I have no credentials on my local machine. So it's not making any calls to the cloud at any point. It's actually doing everything based on what the Pulumi application is doing.
Cool. Paul, we've one other question from Kathleen, looking at the best resource to learn about Pulumi from a student point of view, for maybe somebody who hasn't experience of other cloud management tools or other infrastructure management tools.
And another great point, my battery does look very low. So we have a number of Pulumi resources. Probably the best one to get started with, Kathleen, would be a repository called Infrastructure as Code Workshop, which is a self-paced workshop across a number of different languages, or a number of, there's actually only Azure and AWS supported right now. So if we go and have a look at AWS, for example, in TypeScript, then we have a number of different labs which will take you down through. This is the basics of getting started with Pulumi, making it configurable. Then we can provision some virtual machines. Then we can deploy containers. We can deploy a Kubernetes cluster. actually deploying containers to a Kubernetes cluster, and then lastly, like using like serverless, like deploying serverless applications. So like the serverless is extremely interesting because it really allows you to wrap a lot of functionality away. So firstly, we say, look, here's a DynamoDB table. Then we have an AWS X API. This has a collection of routes. Each route has an associated event handler, and Pulumi understands that everything inside that event handler, so all of that code right there, actually needs to be packaged up as a Lambda. It will resolve the dependencies. So notice that it says result.attributes.hit, and it actually uses the DynamoDB client. It will resolve all of the dependencies as part of that and allows you to deploy all of those dependencies. And it'll take care of all the glue to allow Lambdas and API gateways to talk. So in 34 lines of code, it actually deploys quite a lot of infrastructure in order to actually, not have as much boilerplate code that you would normally need or have to like look through documentation a lot. Great question. What sort of language adoption are we seeing? JavaScript, TypeScript more than Python. So Pulumi as of today supports 4 main language ecosystems. It supports the .NET ecosystem. So C#, F#. If you don't like yourself, you probably could code in VB, but we aren't seeing a lot of people doing it. We unofficially support PowerShell. We also support Go. Go just went live, and C# just went live as part of our 2.0 into GA, so that before they were in preview. We've had Python, and we have JavaScript and TypeScript. So JavaScript and TypeScript is by far our like most used, but it has dropped an awful lot recently. And we're seeing a lot more usage across the board, especially of Python, because very recently, as part of our documentation, we actually released, before like 2 weeks ago, we didn't have any examples for anything in Python, but now we are generating examples in Python. So we have our TypeScript examples, we have our Python examples. Coming this week is our C# examples. And Go examples will be coming in the next week. And since we've actually released that, we're seeing a huge amount of people starting to use other languages away from just the TypeScript and JavaScript ecosystem.
Cool, very cool. Any other final questions before we let Paul go and finish his beer?
I'm already finished.
Christy, once the objects get created by the code in a library, is there a way to change some property in your main code?
I want. Christy, it might be best just to ping me like on that direct question. I don't follow like exactly what you're trying to ask, but it's just only because I'm trying to look at this on an iPad, so I'm probably not following along really easily. One thing, it is important to note that you can share code between different stacks in Pulumi. There are stack references which will allow you to control application B based on the outputs of application A. So maybe that is actually what you're trying to actually say here.
Okay, I think we've got everything covered here. Paul, thank you very much. Thank you for presenting. Thank you for taking the time, and look forward to hearing more from you at some point. Thank you very much for everybody joining us tonight. If you have any requests or suggestions for talks, or indeed have something you want to talk about yourself, please get in touch with either John or myself, and we'll be very happy to put that together. Other than that, stay safe, people. Keep well, and look after yourselves. Thank you.
Thanks so much, folks.
Thanks, everyone.
Take care.
Cheers, folks. Thank you.
Thanks, Paul.